Pluto is hiding something that has left scientists in a state of disbelief, forcing them to reconsider everything they thought they knew. Declassified images from the James Webb Space Telescope have uncovered shocking details beneath its icy exterior. What else might be concealed in the shadows under that frozen shell? Let's explore this groundbreaking discovery that has the potential to forever change our search for extraterrestrial life. The frozen heart of Pluto is hiding something monumental. One of the most astonishing findings is the possibility that Pluto's iconic heart-shaped glacier, Sputnik Planitia, could be covering a hidden ocean. This isn't just any ordinary ice field, it's a nitrogen glacier extending across more than 1 million square miles. Beneath this thick layer of frozen nitrogen, researchers believe there could be a vast reservoir of liquid water. If this turns out to be true, it means Pluto has been defying expectations for billions of years. Alan Stern, the principal investigator for the New Horizons mission, suggests this could be the first clue that life might exist in even the most unlikely corners of the universe. Before we dive deeper, it's clear that what lies beneath Pluto's icy heart is far more extraordinary than anyone ever imagined. And this is just the beginning of a series of revelations that will leave you speechless. Pluto's surface reveals a level of activity that no one anticipated. Despite its small size and distant location, the planet is incredibly dynamic, with towering mountain ranges made of solid water ice rising up to 4 miles high, surpassing even Earth's tallest peaks. What's even more perplexing is the smoothness of certain areas on Pluto's surface. Take Sputnik Planitia, for example. It lacks the craters we'd expect after billions of years of asteroid impacts. Instead, its surface is covered in strange polygonal patterns that suggest a process known as convection, where heat from below causes the ice to move and churn, much like the movement inside a lava lamp. This heat may be driven by radioactive decay. As elements in Pluto's core break down over time, they release enough heat to keep the subsurface ocean from freezing solid. But it's not just the heart-shaped glacier that's puzzling scientists. Pluto's entire orientation appears to have shifted, likely due to the immense weight of the ice in Sputnik Planitia. This shift has aligned the glacier with Pluto's largest moon, Charon, suggesting a fascinating gravitational interaction between the two bodies. The cracks and faults across Pluto's surface provide further evidence of an internal ocean, as they resemble the features we see when a planet's crust moves over a liquid layer. The possibility of an ocean on Pluto raises an intriguing question. Could life exist in this frozen world? Renowned physicist Brian Cox argues that if there's water, life may not be far behind. The ocean's liquid state, insulated by a thick layer of ice, could shield any potential life forms from harsh cosmic radiation and extreme surface temperatures. While Cox remains cautious, he notes that even the discovery of simple microbial life would be a monumental find. The goal isn't to uncover complex life, but to prove that life can thrive in environments vastly different from Earth. Despite the compelling evidence, proving the existence of an ocean on Pluto remains a challenge. New Horizons provided a fleeting glimpse during its flyby, capturing detailed images of only about 40% of Pluto's surface. The remaining areas are still shrouded in mystery, awaiting future missions for answers. Alan Stern and his team are already advocating for a follow-up mission, the Pluto Orbiter, which could spend years examining the dwarf planet in greater detail. This mission could confirm the existence of the hidden ocean and explore its implications for the potential of life. The possibility that Pluto may harbor a subsurface ocean is not just crucial for understanding this distant dwarf planet, it's reshaping our view of the entire solar system. If an ocean can exist in one of the coldest, most remote corners of space, where else might we find water and life? Scientists are already investigating other icy moons, like Europa and Enceladus, which also show signs of hidden oceans. These discoveries suggest that oceans may be more common throughout the universe than we ever imagined. Pluto's icy surface and concealed ocean invite us to ponder where life might exist, but could its fiery beginnings offer even more astonishing revelations, like a hot start that transformed Pluto forever? The implications are vast. Oceans are essential for life as we know it, and the more we discover them in other places, the higher the likelihood that life exists elsewhere. Pluto's potential ocean has led scientists to reconsider the boundaries of the habitable zone, the region around a star where life-supporting conditions might exist. This zone was once thought to end far before Pluto's orbit, but now it appears life could survive much farther out, shielded by thick layers of ice. But how did Pluto's ocean form? Scientists previously believed Pluto grew slowly, accumulating ice and rock over millions of years, leaving it cold and barren. However, recent research suggests a different scenario. Pluto may have formed rapidly and violently, with massive collisions generating enough heat to create a liquid ocean sustained by radioactive decay ever since. This hot start theory challenges our previous understanding of how icy worlds form and evolve. If Pluto had such a hot start, its ocean could have existed for billions of years, long enough for life to potentially develop. And Pluto is not unique. Other dwarf planets in the Kuiper Belt, such as Eris and Makemake, may also harbor hidden oceans. This discovery opens up an entirely new frontier for exploration, as these distant worlds might hold crucial insights into the origins of life in the universe. However, exploring Pluto and its neighbors is no easy task. The New Horizons mission took nearly a decade to reach Pluto, and only spent a few hours collecting data during its flyby. A dedicated orbiter mission to Pluto would take an even longer time, potentially over 27 years, and demand significant technological advancements. The challenges are formidable, ranging from creating spacecraft capable of enduring harsh conditions to developing power sources that can last for decades. The cost is another major obstacle, with a mission like the proposed Pluto orbiter potentially exceeding $3 billion, a significant expense for a single planet. However, for many scientists, the potential discoveries make the investment worthwhile. The opportunity to study Pluto's ocean, geology, and atmosphere in depth could revolutionize our understanding of the solar system and our place within it. While awaiting the next mission to Pluto, scientists continue to analyze data from the New Horizons probe. Each new piece of information adds to the bigger picture, uncovering a world far more intricate and dynamic than previously thought. Pluto's story serves as a reminder that even the most overlooked and distant places can harbor the greatest surprises. Whether it's an ocean beneath the icy surface or evidence of ancient geological activity, Pluto has proven to be a world deserving of exploration. Ultimately, the potential discovery of an ocean on Pluto represents more than just one remote planet. It challenges our assumptions about where life could exist. It invites us to look beyond the obvious and discover wonder in the most unexpected places. While Pluto may be small, its contributions to science are immense, and its secrets are just beginning to be revealed. The possibility of an ocean on Pluto changes how we view distant planets and moons, broadening the scope for life in ways once considered impossible. Even if life on Pluto is incredibly simple, its discovery would revolutionize our understanding of the search for life beyond Earth. Scientists are continually gathering evidence, and each new piece of data makes the notion of an active Pluto with a hidden ocean increasingly plausible. These findings have transformed the once cold, distant dwarf planet from a frozen rock in the Kuiper Belt into a place of wonder, potential, and a symbol of the countless surprises the universe has to offer. Pluto has already revealed extraordinary things, but the rest of the solar system holds even more revelations that challenge our perception of space. From the moon to the farthest reaches of space, our exploration of the solar system has been an exhilarating journey full of surprises, triumphs, and lessons that have reshaped our understanding of the cosmos. This exploration isn't just about planets and moons, it's about uncovering our origins, discovering what lies beyond, and possibly even finding others sharing this vast cosmic playground. Humanity's curiosity has always driven us, with the stars beckoning us to push further into the unknown. Let's move beyond the textbooks and explore what makes this journey so significant. It all began in the 1950s and 60s, when space exploration became a global obsession. The moon, though far from Earth, was the first major target, close enough to reach, but distant enough to feel like another world. The Soviet Union's Luna program initially stole the spotlight. In 1959, Luna 2 became the first human-made object to reach the moon, and the following year, Luna 3 captured images of the far side of the moon, an uncharted territory previously unseen by humanity. The U.S. didn't take the challenge lying down. By 1969, the Apollo program had sent Neil Armstrong and Buzz Aldrin to the moon, proving to the world what humanity could achieve when it aimed high. But that wasn't the end. Mars soon became the next big focus. After all, a planet that might have harbored or still might harbor life is hard to ignore. The first significant exploration came in 1965 when NASA's Mariner 4 sent back images that shattered the dream of lush Martian forests. Instead, Mars appeared dusty, barren, and desert-like. But humanity didn't give up. The Viking missions in the 1970s successfully landed on the Martian surface, searching for signs of life. Spoiler alert, they didn't find much. Fast forward to the 21st century, and rovers like Spirit, Opportunity, and Curiosity began making Mars feel almost familiar with their selfies and discoveries. Then in 2021, Perseverance landed with one major task: to collect samples and hold on to them until someone comes to pick them up. Venus, on the other hand, became more of a cautionary tale. Picture a world hot enough to melt lead, with poisonous air. This is Venus. In 1970, the Soviets managed to land Venera 7 there, though it didn't survive long in the harsh conditions. NASA's Magellan mission in the 90s took a different approach, mapping Venus's surface from orbit with radar. This gave us a closer look at its volcanic terrain, as unforgiving as they come. Then there are the gas giants, Jupiter and Saturn, solar system rock stars. In the 70s, NASA's Pioneer 10 became the first spacecraft to fly by Jupiter, followed by the legendary Voyager missions, which delivered stunning images and data. The Galileo spacecraft, orbiting Jupiter from 1995 to 2003, took exploration to the next level, showing us its moons in breathtaking detail. Io with its lava-spewing volcanoes, Europa with its icy shell hiding a possible ocean, absolutely mind-blowing. And Saturn? The Cassini mission, which orbited the planet for over a decade, changed how we see Saturn's rings forever. It even deployed a probe, Huygens, to land on Titan, Saturn's largest moon, unveiling a world with methane rivers and lakes. Further out lie Uranus and Neptune, the ice giants that don't get as much attention as their closer planetary neighbors. Voyager 2 gave us the only close-up images of these distant worlds in the 1980s, showing that even these far-off planets deserve a closer look. The search for alien life continues, with Europa, one of Jupiter's moons, at the forefront. Beneath its icy surface, a hidden ocean might hold life forms swimming in the dark. NASA's Europa Clipper mission, launching soon, will explore this frozen world, while the ESA's JUICE mission is already on its way to study Jupiter's other moons, including Ganymede, which may also have a salty ocean beneath its surface. These missions are not just about finding microbes, but addressing the profound question of whether we are truly alone in the universe. Human exploration is heating up as well. NASA's Artemis program aims to return astronauts to the moon, not just for a brief visit, but to establish a permanent presence, turning it into a launch pad for future missions to Mars. Meanwhile, SpaceX is making strides toward interplanetary travel, pushing the idea that humans could one day live on multiple planets. Earth may serve as the launch point for future space exploration, but the ultimate goal is to stretch beyond our home planet. Exploring the solar system is not just about gathering data, it's about dreaming big and challenging limits. Each mission and discovery brings us closer to a future where humans don't just live on Earth, but thrive among the stars. The journey has only just begun. The real question isn't whether we'll continue exploring space, but how far we're willing to go. The quest for answers in space continues with Mars rovers uncovering unexpected findings on the Red Planet. These robotic explorers have been tirelessly navigating Mars's dusty, rocky terrain for decades, helping scientists piece together its history, from its ancient landscapes to its evolution into the planet we see today. Over the years, several of these rovers have traveled from Earth to Mars, each equipped with tools designed to uncover new secrets about our neighboring planet. Then there's the hunt for life, real alien life. We're looking at places like Europa, one of Jupiter's moons, where a hidden ocean might harbor something swimming around in the dark. NASA's Europa Clipper, set to launch soon, will investigate this icy world. ESA's JUICE mission is already on its way to study Jupiter's other moons, including Ganymede, which also might have a salty ocean beneath its crust. These missions aren't just about finding microbes. They're about answering the age-old question of whether we're alone. Human exploration is heating up too. The Artemis program aims to return humans to the moon, not just to visit, but to stay and use it as a launchpad for Mars. SpaceX is making significant strides with its vision for interplanetary travel, advancing the idea that humans could eventually become a multiplanetary species. Earth could serve as the launchpad for future space missions. The bigger picture isn't just about collecting data. It's about expanding our horizons and pushing the limits of what's possible. Every mission, every discovery, brings us closer to a future where humanity not only inhabits Earth, but also thrives beyond it, across the stars. The journey ahead is long, and the real question is not whether we will continue to explore space, but how far we're willing to go. The quest for answers about space persists, and Mars rovers have uncovered surprises about the red planet that no one anticipated. These robotic explorers journeying across Mars's dusty and rocky terrain have been key to piecing together the history of the planet, its appearance millions of years ago, and its transformation into the Mars we observe today. Over the years, several rovers have made the incredible voyage from Earth to Mars, each one equipped with tools to uncover new secrets of the red planet. Let's start with Sojourner. This small rover marked NASA's first successful attempt at driving a robot on Mars. In 1997, on July 4th, Sojourner landed in a region called Ares Vallis. With just 6 wheels, it was designed to test the viability of this technology and gather basic information about Mars. Equipped with a camera and an X-ray spectrometer to study Martian rocks and soil, Sojourner was initially meant to last only 7 days. But it exceeded expectations, remaining active for 83 days and sending back valuable images and data that paved the way for future missions, offering a never-before-seen look at Mars. Years later, Spirit and Opportunity followed. These 2 rovers, part of NASA's Mars Exploration Rover mission, landed on opposite sides of Mars in 2004. Spirit arrived in Gusev crater, while Opportunity landed in Meridiani Planum, a flat plain. Though they were only expected to function for 90 days, these resilient robots outperformed expectations. Spirit continued working until 2010, and Opportunity lasted until 2018, setting endurance records on Mars. They uncovered groundbreaking evidence, such as minerals that form in water and signs of ancient lakes, challenging the belief that Mars has always been a dry and desolate world. Curiosity arrived in 2012, a rover unlike any before it, larger and equipped with cutting-edge scientific instruments. It landed in Gale Crater, an area scientists believed had once hosted water. Since then, Curiosity has been on a mission, discovering further evidence of freshwater lakes and organic molecules on Mars. These molecules are key because they could suggest that Mars once had the essential ingredients for life, even if only tiny microbes. Curiosity's findings have drastically changed our understanding of Mars, and it continues its work today, climbing hills and drilling into rocks. Next came Perseverance, landing in Jezero Crater in 2021. This rover's focus is on the search for signs of ancient life, collecting rock samples that may one day be returned to Earth for in-depth analysis. And let's not overlook Ingenuity, the small helicopter that accompanied Perseverance. Ingenuity made history as the first aircraft to fly on another planet, a remarkable achievement. Perseverance continues to explore what was once a river delta, offering scientists new insights into Mars's watery past and the potential for life there. But NASA isn't the only one making strides on Mars. In 2021, China's space agency entered the field with the Zhurong rover, which landed in Utopia Planitia, the vast plain on Mars. This marked a major achievement, making China the second country to successfully operate a rover on the red planet. Zhurong's mission focuses on studying Mars's surface and probing beneath it with ground-penetrating radar. The data it gathers is contributing to the larger puzzle of Mars, providing valuable comparisons to other findings from around the planet. Each rover mission builds upon the successes of its predecessors, expanding our understanding of Mars. From discovering minerals linked to water to uncovering evidence of ancient lakes and signs that the planet may have once harbored life, these robotic explorers have played a crucial role. They're also laying the groundwork for the eventual arrival of humans on Mars,